Alright, so today we're going to be doing lesson 5.4, which is geometric series. So we've talked about arithmetic sequences, arithmetic series, geometric sequences, and now we're going to be talking about geometric series. So as we know, a series is where we take a sequence and we add up all the terms. So a geometric series corresponds with a geometric sequence, as you could have guessed. So moving on to the next slide. We're going to talk about basically the idea that the geometric series are the sum of the terms of the geometric sequence. And in this case, we would be able to tell that this is a geometric series, or why? What's the pattern here? And you can look at the pattern in the sequence as well. What are you noticing happening each time? Multiplying by 2. Good, so every time we're multiplying by 2 to get to the next term. And you always want to confirm that with all the terms that you're provided. There's not going to be an extensive list. Look through and make sure it works. So yes, it is geometric because we have what we call a common ratio. And the common ratio here is 2. Excuse me. So, to find the actual geometric series, we're going to add up all of those terms. So 2.5 plus 5 is 7.5. 7.5 plus 10 is 17.5. 17.5 plus 20 is 37.5. And 37.5 plus 40 is 77.5. 77.5. So that would be the geometric series because it's the sum of the terms of the finite sequence. So moving on to the next one, we have the sum of a finite geometric sequence. In this class, we're not going to be going into infinite sequences or series too much. We're going to talk about finite. Eventually in the future, if you take enough math classes, you will talk about that though. So this is the formula. You have the summation, which you guys know means addition, meaning reoccurring addition, which we learned about when we did arithmetic series. So you take the first term times the common ratio to the power of n minus 1. You'll also see it written as I minus 1 or I sometimes, same thing as n. And we talked about the formula in a separate box when we did arithmetic, but basically this is equal to the sum of n terms, which is equal to a sub 1 is equal to 1 minus r to the n over 1 minus r. So this portion right here of the formula is what you use if you want to add up like 30, 40 terms. Because if you use the summation to do that, if you use the summation over here to do that, you're going to be sitting there calculating each term individually and then adding them up. The sum formula allows you to find the sum in one step, you know what I mean? So that's why you want to use the sum formula when you're adding up a bunch of these. So just to go through the vocabulary here, A1 is the first term, N is the number of terms, and R is the common ratio. Nothing's changed since the last lesson. And R is never going to be 1. And it's also never going to be 0. Okay, but R is not going to be 1. Why could your common ratio not be 1? What would happen if it was? Let's say I have a sequence starting with 5, and the common ratio is 1. What's the next term going to be? No, it would just be, if it's a ratio, it's just going to be multiplying by 1. So it's just going to be 5 again and again. So is this even a real sequence? It's just a repetitive situation, okay? So that's why you want to think of the fact that you can't have R to be 1. So moving on. Let's go ahead and look at example 1. So it says, find the sum of each finite geometric sequence. So in this question, the first thing you're going to want to do is find the first term in the common ratio. So what would be our first term here? Good, negative 15. And my common ratio is what? Negative 2, because every time we're multiplying by negative 2. And we know that our common ratio is always negative if the terms are alternating signs. So if it's going positive, negative, we know that our common ratio has to be negative. So once we've identified A1 and R, we want to find the sum of the geometric sequence, but they also want us to set up the general form of the actual summation itself, the summation notation. So what we do is we write out the summation, and we're starting at n equals 1, and we're going through up to how many terms we have. So how many terms do we have in this particular sequence? 6. And then we take our first term, which is negative 15, times our common ratio to the power of n minus 1. So that's the general formula for a geometric series. Okay, that's how you write a geometric series in summation notation. Now we're going to calculate Sn. Okay, Sn. So Sn is calculated by taking the first term. This is just right from your notes, right above it. The formula I'm using is the one right above this part. So your first term times 1 minus the common ratio to the power of n over 1 minus the common ratio. So that's the general formula for the sum. Now in this case, we want to calculate the sum of 6 terms. So what are we going to be plugging in for n here? We want to calculate the sum of the first 6 terms. Good, we're going to plug in 6 for n. So that's because there are 6 terms that we're adding up. So we do this math in our calculator, the easiest way to do it. So 1 minus negative 2 to the 6th power divided by, what's 1 minus a negative 2? Good, you add it. And then times 15. And you're going to need your calculator for this, of course, but the answer comes out to be 315. So what that means is the sum of these 6 terms is equal to 315. So if you added them all up, you would get 315. So do I have any questions about part A? Okay. Let's move on to part B. So on part B, the first thing you want to identify is your first term, which is what? Good. And then what is your common ratio? Good. So your first term is 3 and your common ratio is 2. So let's write our summation notation. But I have a problem here. Do we know how many terms there are in the sequence? No. So we're going to have to figure out how many terms there are. Now I would never give you one that's going to be too lengthy, but this one's actually not too bad. So this is your first term, second term, third term. We don't know what the fourth term is, but we could find it by multiplying 12 by what? 2. We get 24. We're going to multiply 24 by 2. We get 48. Multiply again, 96. Multiply 192. Multiply 384. We multiply 68, not 86. And we multiply again, and we get 1,536. So we ended up where we wanted to be. So like I said, it wasn't that many terms. I wouldn't ask you to do like more than, 10. So what term is this term based on what we just figured out? What number term is it? The 10th. It's the 10th one. This is A1, A2, A3, A4, A5, A6, A7, A8, A9, A10. It's the 10th term. So now that we have that information, we can set up our summation. Hang on. Hello? Hi. It's good. How are you? Yes. Sure. You're welcome. Bye. All right. Anyways, okay. What was I saying? Okay, so we're going to set up the summation. So the summation is n equals 1, and we're going to how many terms? How many terms are we doing here? 10. is equal to your first term times your common ratio to the n minus 1 power. That's your summation. But we now want to calculate the actual sum, so we're going to use the sum formula, which is S sub 10, so we're looking for the sum of the first 10 terms. And that's going to be 3 times 1 minus 2 to the 10th power over 1 minus 2, like that. And if you do this math in the calculator, you would get 3,069. You can check that if you want, but that's what you would get if you do this in the calculator. So just make sure you practice how to type this in. If you have one of these calculators, the 300 or the 330XA, which is the one you use for geometry and algebra, I can show you how to do it. Just let me know and I'll help you out with it. Any questions on B? Alright, let's move on to C. So in C they already gave us summation notation. Now we just want to actually calculate the sum. Now instead of actually calculating all of these terms separately and adding them up, we're going to use the sum formula. So in order to use the sum formula, you need to identify the first term. And looking at this summation notation, what's the first term in this? 5. So you can always identify the first term in a summation notation because it's the term that doesn't have any exponents on it. You see that? So then we can identify the common ratio, which is always the one that is to the n minus 1 power. Okay? That's always your common ratio. And then you can identify the n because it's what's on top of the summation itself, which is the 10. Everybody see how I got those 3 pieces of information? Now that I have that, I'm going to sub into the formula. So it's S, the sum of the first 10 terms, is equal to, and the formula goes as the first term times 1 minus your common ratio to the n power over 1 minus, once again, your common ratio, close parentheses. And then we would just calculate this in the calculator. Like I said, if you need help typing this in, let me know. I can help you out at the end of the lesson. And this one comes out to be negative 1,705 when you do that math. So that is how you get this answer. So does anybody have any questions for me on that? Does it make sense? Could you do it on the test? Okay. Alright, let's try D. So there's something weird about D when I look at it. What do you notice about the n in the beginning here, n equals? It's equal to 0, but what is it usually equal to? 1. So in this case, we usually start with our first term being called A1, but here we're starting with the first term A0, which means that if you're adding in A0, how many more terms are you going to have? 1 more term. So if you're starting at n equals 0 instead of n equals 1, that's actually going to be 25 terms, because 1 through 24 plus 0, another term, 1 more term is 25. So your n here is actually not 24, but it's actually 25. So if you ever start at 0 instead of 1, make sure you add 1 back to your term on the top there. Okay, very important. Alright, so now that we have that information, we're now going to find A1. And what is my A1 in this case? Good. And what is my common ratio here? 1/2. So now that I have all that information, I'm going to sub into the sum formula. So I want to find the sum of the first 25 terms, which is equal to my first term times 1 minus my common ratio to the power of n all over 1 minus 1/2. If I compute that in the calculator, your answer is going to come out to be approximately. So in math, if you're going to calculate something and you have to round it, use this symbol right here, these wavy, like almost like the Aquarius symbol, if you know what that is, wavy equal sign, and it's approximately 6. So if you do that calculation, you get approximately 6. So any questions about D? All right, let's move on to the next slide then. So the next slide says, express in summation notation the first 6 terms of the series. So in this case, it doesn't want us to actually calculate any S, like the sum. So make sure when you take the test that you read the questions, because some of them are going to ask for you to calculate the sum, and some of them are going to ask about your summation notation. Summation notation is just the setup. The sum is going to be a number. Does that make sense to you guys? So if you're looking for the sum, it's going to be a number. If you're looking for summation notation, it's going to have that big E symbol in it, okay? So they only want the notation this time. They don't want the answer. So the notation, in order to get the notation, we need to know the number of terms, n. We need to know our first term, which is? Good. And then we need to know our common ratio, which is? 5, because each time 3 times 5 is 15, 15 times 5 is 75. That's where the common ratio comes from. Now that we have all that information, we're going to set up our summation. So we draw a summation. We're starting at n equals 1, so when you make your own summation, unless otherwise stated, you can always start at 1. It makes your life easier. We're going to 6 because we're calculating the sum of all 6 terms. And then it's going to be your first term times your common ratio to the n minus 1 power. And that is your final answer on that. So that's how you do it. So do we have any questions about how to do example 2 before we move on? Alright, so moving on to the next, we're going to do example 3. So it says express in summation notation the first 10 terms of the series. Okay? So, first thing we do is identify our n, which is 10. That's how many terms we want to set it up for. And then what is the first term here? What's the first term in this series? Oh, see, like this is the second term right here, -1. But remember, they actually are just adding or subtracting them. So they're technically just doing adding a -1 here. Yeah, it's kind of weird how it's written, yeah. So yeah, the answer here is 2. The first term is 2. Now, to get from 2 to negative 1, what would you multiply 2 by to get to 1? -1/2. Good. So your common ratio here is -1/2. So to get from 2, if I write it as a sequence so you guys can kind of better understand it, this is it written as a sequence. So to get from 2 to -1, you have to multiply it by -1/2. And to get from -1 to +1/2, you'd again have to multiply by -1/2 and so on. So sometimes if you write it as a sequence, if it looks confusing like this, that will still help you. That will also, make sense and help you see the common ratio better. So now that we have all of that, we're going to set up our summation. We're going to start at 1. We end at 10. It's going to be our first term times the common ratio to the power of what? Anyone remember?
N minus 1.
Good, n minus 1. Good. Do we have any questions so far? So now we're going to do a real world problem before we do homework. Okay. So it says your parents ask you to work 8 hours each day during the month of July. In exchange, they offer to pay you 1 penny for the first day, 2 pennies for the second day, and 4 pennies for the third day. They're going to continue in this pattern until like the end of the month. Is this a good offer, and would you accept it? What do you guys think? Who thinks it's not a good offer? Would you guys accept working for a penny, then 2 pennies, and then 4 pennies? Are you sure? Okay, let's see what it comes out to be. So, the first one that you're going to come out is it's going to be a penny, which is, you know, that much out of $1, right? The next term would be 2 pennies, and then it would be 4 pennies, right? So our first term is 0.01, right? That's our first term. What is our common ratio? What are we multiplying by each time? 2. Good, because you go from 1 penny to 2 pennies, multiply by 2. 2 to 4 would be multiplied by 2. And the number of days that we're going to add up are going to be the number of days in the month of July. Anybody know how many days there are in the month of July? 31. Good. So our n is going to be 31 here, because that's how many days are in the month of July. I had to think about that one when I first did this. I thought it was 30, but no, it's 31. June is 30. Anyways, so we don't care about summation notation. We just want to find the sum. So we're going to use the sum formula, which is the sum of the first 31 terms. We'll wait for this. We're going to find the sum. We're going to find the sum of the first 31 terms. That'll be all the days of July. And it will be the first term times 1 minus your common ratio to the n minus 1 power over 1 minus your common ratio. So we'll do that calculation in steps, okay? So that's going to come out to be the sum 31 is equal to, now here if I put 2 to the 30th power in the calculator, it's already overwhelming my calculator. So it's going to be really big. And when I actually plug all of this into the calculator, you guys are not going to believe the amount it is. 21454836.47. Put commas in. And if you took this offer, you would have made over $21 million. Yes.
Is it supposed to be 31 times? I don't believe it.
Oh, I'm sorry. Yeah, you're right. My mistake. It's not minus 1, it's just 31. It still comes out to be that amount. I just put that. That's from the other notation. Sorry. It's just n. I was like mixing it up with the sum one. Yep. Just like that. So yeah, if you would have taken this deal, you would have made over $21 million. So the idea here is